Awesome, and we're live. Welcome here, everyone.
Hello.
Hey guys.
Hello.
Thanks so much for joining us today. Let us know in the chat where you are tuning in from. Actually, we'd like to see where everyone's joining from. We are starting a few minutes early today because we do have also a little bit of a fun icebreaker to kick things off. So yeah, let us know in the chat where you're tuning in from. And also, if FME could magically create a transformer to solve any of your daily life problems, what would it do? And I'm going to pass this question over to the team as well, but I had one in mind, and it would be the laundry launcher. It just automatically sorts, washes, dries, and folds all my clothes without lifting a finger. I can't stand laundry. It's like the worst chore in my opinion.
I agree, and sticking with the laundry theme, I came up with the sock folder. A little more specific, but my absolute least favorite task when it comes to household chores is matching and folding socks. If I could have something that just did that for me, I would love it.
I think I have a pretty good one. I would have whatever ingredients I have in the fridge. It will give me a good recipe to make the use out of the rest of them. Just get rid of it.
Oh,
That would be a good one.
I've used
Yeah,
time or two for that, but it's
that
so
works
annoying.
too.
You have to type it all in and figure out maybe if the transformer just automatically did it for you.
Exactly, yeah.
Yeah, I like the idea of a pet translator as well. You can kind of see what your pet is thinking.
Like Cloudy with a Chance of Meatballs style. Anybody ever see that?
Yeah.
That's a little like chest pack for his monkey. That'd be great.
Totally. If you're just joining us now, we just went through a little bit of an icebreaker. If FME could magically create a transformer to solve any daily life problem, what would it do? I'm looking forward to reading through everyone's responses in the chat too. But in the meantime, we are at the top of the hour. But feel free to keep dropping in ideas. In the meantime, I would love to welcome everyone to our webinar today, Safer's Picks, FME Transformers That You Didn't Know You Needed. So very excited for this webinar. We are joined by our SAFE expert panelists today. And I'll pass it over to each of them to introduce themselves briefly. So we'll start off with Donal.
Hi guys, excited to talk to everybody today. I'm Donal, originally from Ireland, but I've lived in Vancouver for about 7 years now. And within SAFE, my interests would be raster imagery and GIS.
Yeah, I'm Crystal Fitzpatrick. I'm located in Vancouver, BC, and I'm a technical support specialist on the FME Forum team.
Awesome. And Evie.
Yeah, hi, I'm Evie LaPalme. I am a technical support specialist on Form as well, and I work a lot with CAD, 3D, and anything GIS as well.
Hi, everybody. I'm Natalie. Like most of my colleagues here, I'm also a technical support specialist. I dabble in pretty much anything that's out there, but I tend to do a lot with web services and databases as well.
Hi, my name is Dave. I'm interested in schemas and AI applications and workflows.
Fantastic. Thanks, everyone. And my name's Elizabeth. I run our webinar program here at SAFE and really excited to be joining these presenters today. Just briefly here, before we dive into the webinar, a few quick pointers if you're newer to the Livestorm platform. If you have any audio issues during the webinar, just click that help button on the bottom left for 4 simple steps to take. You can share your emoji reactions with us using that react button on the bottom middle. Questions. If you do have any questions at all during the webinar, as we go through here, please do drop those in the questions tab, and we'll be keeping an eye on that during the webinar. And then we'll also have dedicated time at the end to answer those live. And then lastly, keep letting us know in the chat where you're tuning in from, or share any comments you have during the webinar with us there. All right, and just to go over our agenda here briefly today, I'll take us through here. So we'll be kicking things off following an introduction with Donal and the MapnikRasterizer. From there, we'll be going through the SchemaScanner that Crystal will be taking us through some tips and tricks on. And then Evie will be going through the aggregator and some insights on that transformer. The raster expression evaluator is next by Natalie. And then last but not least, it will be the change detector that Dave will be presenting on. Then to follow, I'll take us through some wrap up and resources to help you get started. And then we'll have that Q&A session to follow. All right, at this point, I will ask our presenters to turn off their webcams just so we can save on some bandwidth for the remainder of the webinar here. And we have a chat question for you all. We'd love to know, what is your all-time favorite transformer so far anyway, because that could change after today. You never know. Maybe you have one or two go-tos. We'd love to read through those in the chat. So we'll just give everyone a few moments to drop that in. Because we have so much great content to get through today, we'll probably take a look at those results a little later on here. But yeah, really excited to read through what everyone's favorite all-time transformer is up to this point anyway. Okay, so I'm just going to take us through a brief introduction to today's topic. As you may know, FME is packed with powerful transformers. Some of them you may know and love, and others might feel more in the hidden gems category for you. FME is home to over 500 transformers. So while you might have your go-to favorites, of course, the sheer quantity that there is, there's always going to be something new that you can learn and leverage to make your data work to the fullest for you and leverage the power of FME even further. But today we're going to be discussing these hand-selected transformers that our team has picked out to take your workflows to the next level. So maybe these are ones that you've overlooked in the past, or maybe just have yet to fully leverage or even hear about, to be fair. So our goal is to showcase these 6 that will ultimately save you time, maybe even gain further insights from your data than you thought otherwise possible. These will include ideas that you can immediately apply to your own workflows. So we anticipate that you will leave the webinar today with some new things to get started with trying out right away. If you're newer to the FME platform, allow me to give you just a brief overview before we hand things over to Donal here. So our FME form is the authoring environment where you build your data integration workflows. And then automation can be provided in FME Flow. This is deployed on-premise or in your private cloud. And then we also offer FME Flow hosted. So the infrastructure is taken care of for you there. No matter how you use FME, we trust that these transformers we're sharing today will help you get even more out of it. And with that, I am excited to pass things over to Donal to take us through the MapnikRasterizer.
Thanks, Elizabeth. I'm going to kick us off here with one of my personal favorite transformers, the MapnikRasterizer. What is the MapnikRasterizer transformer? This transformer generates a raster from input vector and raster features with fine control over symbolization and labeling using the Mapnik toolkit. It's an extremely powerful tool and allows for easy creations of cartographic renderings of vector features or vector on raster features. So how does the MapnikRasterizer work? Styling is done using Mapnik symbolizers, which you define in the transformer parameters. Taking a look at the table on the slide, it outlines what styling options you can set in each symbolizer. Today I'm going to run through some demos for you guys. I'll have multiple examples that run from an introduction level to expert level, demonstrating the power and possibilities of the MapnikRasterizer. I'm going to kick us off with an introduction into the MapnikRasterizer transformer.
In this first demo, we will create an FME workspace that reads in a shapefile of the country of Ireland. We're going to use Mapnik to style the geometry and generate a raster in the form of a PNG. The source dataset contains a single polygon, and we will use multiple Mapnik symbolizers within a single transformer to style it. We'll walk through the MapnikRasterizer parameters and style a map of Ireland by setting the background and geometry colors. This basic styling is designed to get you familiarized with Mapnik symbolizers. As you can see, our source data is the outline of Ireland. We're going to add in our MapnikRasterizer and connect it to our source. Once you open the MapnikRasterizer, you'll be greeted with several sections which we'll configure along the way. The rendering rules section tells Mapnik how to style the input features. This is where you use Mapnik symbolizers. Layers are drawn in the order that they appear in this table, with the top drawn first. We're going to add a rule to style the geometry using the polygon symbolizer. We're going to color the polygon green, an appropriate color for the country. Notice there's also sections for smoothing and more. We can ignore these for this example. We're going to add a second rule. This rule will use Mapnik's line symbolizer to treat the input polygon as a line and make it orange. The line parameters come with the ability to also change its style, positioning, smoothness, and more. We can leave these the same for now. The raster properties section defines the number of rows and columns or cell size, as well as the interpretation type, RGB24 or RGBA32, etc. I'll change the cell spacing and set a cell spacing of 0.10. The background section allows setting the background image or color and opacity. I'll change it to a nice cyan color. The ground extents section allows you to manually set the extents of the output raster. By default, the extents are defined by the input features, but sometimes it's necessary to adjust the boundaries of the map depending on how you have styled it. For this example, I can leave it as it is. We'll run the workspace and show you the changes made to our polygon. In the second part of this demo, I'm going to show how easy it is to make changes and show you how to bring in images and text. I'll open up the MapnikRasterizer and we'll change our polygon to a polygon pattern. I will then add in a picture of the Irish landscape. We will change the alignment to global and everything else will remain the same. Next, I'd like the name Ireland to be visible across the center of the polygon. I'll add a text symbolizer and make the appropriate changes. I'll change the font size and the color to green. I'll also add an orange halo to our text. For positioning, we'll also say yes to avoid edges and have the placement set to interior. Finally, we'll add a point symbolizer. I'd like to add the Irish coat of arms to be slightly visible in the background. We'll add the image and we'll change the opacity to 0.3 and change the placement to centroid and allow for an overlap. We're going to write this out to a PNG file and run the workspace. As you can see, the MapnikRasterizer allows for easy customization and the ability to make creative and colorful cartographic renderings. Now that we've got a taste of the MapnikRasterizer, I'd like to quickly show you 3 more examples of what this transformer can really do. For example 2, we already have built out a workspace. In this scenario, the MapnikRasterizer adds a 3D element to a 2D map by styling buildings using a height parameter and extruding polygons and text labels. We'll have a quick look in the visual preview, but as you can see, there's a cool 3D element on a 2D map. For our next example, I'll show you how the MapnikRasterizer can create textures. In this workspace, we apply random textures to polygons and lines. This highlights the capabilities of creating beautiful maps using the MapnikRasterizer. The details and colors that are shown here looks like a tapestry over the city of Vancouver. The final example that I will show highlights just how much you can do with the MapnikRasterizer. In this example, we create contour art from an image of a face. This shows just how creative people can be when working with this transformer and just how powerful this transformer is. When zooming in on the visual preview, it shows each individual contour line adds up to make a face. This is a very impressive creation using the MapnikRasterizer.
So that concludes the demos I'll be showing you today. So we're going to go over some key takeaways regarding the MapnikRasterizer. There are many possibilities while using this transformer, and they include advanced cartographic stylings, high quality raster renderings, labeling capabilities, multi-layer support, and much more. It truly is a great transformer. I'm now going to hand it over to Crystal, who's going to go through another personal favorite of mine, the SchemaScanner.
Thanks, Donal. I will now be covering the SchemaScanner. So the SchemaScanner extracts the schema from incoming features by scanning for attribute names and data types. The schema is stored in a schema feature, and a visual representation of the schema feature structure is just displayed on this slide here. The SchemaScanner can be leveraged to generate a schema feature for dynamic writing, schema validation, and schema drift, or generating new schemas after merging or manipulating your source data sets. So today I'm going to be going over detecting schema drift and dynamically setting your output schema based on incoming data. The first scenario that I want to highlight is how the SchemaScanner can help detect schema drift. This happens when the schema or data model of your source dataset changes unexpectedly. The SchemaScanner transformer can be used to detect and react to schema drift in our datasets. The scenario here is that we want to update the base dataset from a new dataset uploaded by a client. So just looking at the screenshot here, this shows the base dataset and the new data upload. You can see that the attributes don't quite match. So in the new data upload, the path length from the base dataset was named distance, and the path type is missing. So tying this into the first screenshot, we have added a SchemaScanner transformer to both the original dataset and the updated dataset. So this allows us to compare the schemas before proceeding with the update of the base dataset. A schema is then compared using a change detector. And then finally, this example creates a schema change report. So as you can see on the right side of the screen here, this will provide feedback to a user either through email or an FME Flow app. So for more information on how to use the SchemaScanner to detect schema drift, you can check out the article that is linked at the bottom of the slide here. The final topic I'll discuss is dynamically setting your output schema based on incoming data. So I'll be demonstrating how you can transform the schema that you're working with. So we'll be extracting the schema from incoming features and dynamically transforming the final schema based on the source data. So in this demo, we're using a few transformers along with the SchemaScanner transformer to take the incoming fruit data schema and dynamically setting the schema to create an inventory table with a set of attributes to account for each variety of fruit. So on the right side of the screen, you can see the source data, and then at the bottom is our desired result that shows a set of attributes for each fruit variety. While this is a simple example, for a more real-world use case, you can check out the webinar that's linked at the bottom of the slide as well. So now I'll be going into the demo on dynamically setting your output schema based on incoming data. Okay, so the first part of this workspace is just reading in the CSV file. So the file has 3 fruit types. So we have apple, mango, and pear. And then for the fruit name, so in this case, we have 5 apple varieties. So our goal is to have an output with 5 sets of attributes to account for those different apple varieties. Say we had 10 apple varieties, then the output would have 10 sets of attributes. We also have price per kilogram, and this is in Canadian dollars, and then the country of origin. So just moving through this workspace, we have our schema scanner here. So the input into the schema scanner comes from the list breaker. So we have pear, apple, and mango here. And then we have our different fruit varieties in a list. So there are many parameters you can use depending on your use case. For this example, aside from the default values, I chose to ignore certain attributes that aren't needed in our output schema, and then also how to handle any missing, null, or empty attributes. So once you run the schema scanner, the resulting schema feature is comprised of a list attribute following the structure name and feature data type. And then the original input features are just passed through the output port here. Okay, so next we're going to create the destination schema feature. So the transformers at the bottom here are used to set up a schema feature for the intended output. So I can show you the output of the list exploder where you can see the schema attributes that we extracted by the schema scanner along the scanner. The resulting schema feature is comprised of a list attribute following the structure name and feature data type. And then the original input features are just passed through the output port here. Okay, so next we're going to create the destination schema feature. So the transformers at the bottom here are used to set up a schema feature for the intended output. So I can show you the output of the list exploder where you can see the schema attributes that we extracted by the schema scanner, along with some indices that we created earlier in the workspace that will help us with sorting the attributes for our desired output. Moving through the workspace, you can go to the attribute keeper here. So this essentially ordered attributes required for the output. So the set of attributes from the first variety, second variety, and so on are all grouped together. And then lastly, we have the list builder. So what this did was just generate the schema feature. The last transformer that we'll use in this workspace is the feature merger. So what this does is it takes the output of the destination schema feature and it will merge it with the original input schema features. So lastly, we want to write out a CSV file. So you just want to make sure that the dynamic schema definition is selected here. And then the schema source, you want to set it to schema from schema feature. So now we can see that our final output has the first variety, second variety, and so on all grouped together here. So just to wrap up, I showed that the schema scanner can be used for multiple purposes, including detecting schema drift and dynamically setting output schema based on incoming data. It can also be used for things like schema validation and generating schema. I'll now pass things over to Evie.
Thanks, Crystal.
The aggregator is a powerful transformer that combines features, concatenates attributes, and aggregates geometries. Use the group by, otherwise you will have only one feature. So you can see that in the image there. You can use the aggregator for attributes, concatenate your strings together, or if you need different functionality from the feature merger or feature joiner. You can also use this for geometry. So like how can you combine duplicate features in the same data set, or you have features that do not touch, but you need them to be in the same feature. So I will go into the demo. Okay, so this is FME 2025, and I have two files here, a CSV and a GeoDatabase. And if I run that, you can see that they both have 1,000 features. In one of them, I have the CSV has a bunch of data here, property address, year, square feet, and this is the ID that I will be joining them on. The parcel data, the geodatabase has a bunch of parcel data in it, and it only has the roll number as well as an object ID. So you could use a feature joiner, or you can use an aggregator. I'm going to add an aggregator to the canvas here and connect them. In here, I can use this. I'm going to use the group processing and select the common attribute. They are both named the same, otherwise this would not work. I'm going to assemble on one level and merge incoming attributes, and I'm going to leave them all the same since none of them overlap. And click OK. And if I run that, you'll see that they have all been merged. I have 1,000 features still, and now all of them have all of the attributes that I need. Yeah, and then for the next example, I have a parks geodatabase down here. And you can see that in this data, it's all of the parks in Metro Vancouver. It has a lot of information here, as well as a lot of sub-administrative areas. But I've noticed that some of the parks are in different features for the same object ID. So I want to confirm if that's true with the duplicate filter. And if I run that, I'm going to select the object ID. Global ID works as well. Yeah, okay, so there's 146 duplicates for the global ID. So I could do this in one of two ways. I could dissolve them, assuming that they are touching, they would be dissolved. So I could do automatic and group process on the global ID, and that would work. But for attributes to sum, there isn't an option to concatenate. It's only if they have attributes that are numeric, they would be summed here or averaged, but all of the attributes will be taken. So that is an option. You see here that now there's the same amount. This is the same number, but it doesn't quite get the same stuff. Like if there was different sub-administrative areas for the different polygons, maybe it might not combine those or capture all of the information that you need here. So I'm going to add an aggregator. And instead, we're going to do the same thing, have this be on global ID for group by, and I'm going to merge incoming attributes. But for this case, I'm going to select the sub-administrative area. And I know that they have some of them are different. Everything else is the same. It's the same number. When I go to the sub-administrative area here, you might see that some of them have multiple results. See, like this example here. This one has a lot of different polygons that have been joined and a lot of different attributes here. There's only 3, so it might need some post-processing here to limit these. It just shows you that there are some that have been concatenated. Great. So, warning, not all writers support aggregate or multi-geometry. Just remember to dissolve or deaggregate your features before writing if needed. And also something that I didn't go over in the demo is that there is another aggregate mode that is assemble hierarchy. This is used for parent-child relationships if you need them in your data. And with that, I'll pass this on to Natalie.
Thanks, Evie. Now let's take a look at a couple of ways to recycle raster band expressions with the raster expression evaluator transformer. First off, the raster expression evaluator allows you to perform cell value manipulations on single or pairs of rasters. The images seen on screen are showing how the raster expression evaluator can be used to transform a multi-band color image into a single band grayscale image, but other composite images are very possible to generate with this transformer. Looking at the parameters dialog of the raster expression evaluator, though, it seems like manual entry of raster expressions is required, and the formatting of these expressions is pretty unique to FME. So both of these points can result in expression entry errors. Today, I'm going to show you 2 different ways you can recycle your raster expressions so that you can avoid that repeated manual entry of your commonly used expressions. There are actually quite a few ways available to achieve this goal, but it's not always obvious where to find and apply them. The 2 methods I'll demonstrate today will be the use of transformer presets and the use of a choice published user parameter, both of which will help alleviate that repeated manual entry of raster expressions, thereby reducing errors due to manual entry. So let's get into those demos. So here I am in FME Workbench 2025, and I'm showing a fairly simple workflow. All I'm doing is reading in a series of Sentinel-2 image bands, bringing them together into a single raster with the raster band combiner, and then sending this multi-band image over to the raster expression evaluator, where I'm going to generate my composite image of interest. So as I mentioned previously, working with the raster expression evaluator can be a bit challenging. Beyond the need to format your expressions in a way that FME understands, it also looks like you need to manually enter these raster expressions every time you want to use this transformer. And some of these raster band expressions can get quite complex. This isn't an ideal scenario, as manual inputs are, of course, prone to error. So this is where parameter presets can come in really handy. Parameter presets are valuable anywhere you find yourself entering the same value repeatedly while configuring really any given transformer in FME. With presets, you only need to manually configure the parameters of a transformer once, and then you can save the whole configuration as a preset to be reused again and again with just a couple of mouse clicks. So let's take a look at a raster expression that has been saved as a preset. So all you have to do to see if you have any presets available to you is just select the presets button at the bottom left of the transformer. Now I can see a whole bunch of these load options. These load options are all of my presets. These are all of the equations that I've already configured for my raster expression evaluator. So watch what happens when I select one of these. I'm going to select NDVI because it's one of my favorites. You can see that all of the parameters are now configured for the raster expression evaluator exactly how I want them to be. So now if I want to add a new preset to my raster expression evaluator, all I have to do is configure the transformer's various parameters once, select presets, and I'll just do it once here, save as, new preset, and then just give it a name. So I'll just go NDVI2. And now if I go back into my preset options, I'll see a load NDVI2 option. So all of the presets that I showed you here, I actually created all of these and saved them all out in FME Form 2024.2. And now I'm seeing them in FME Form 2025. If I were to actually switch over to an older version of FME, say FME Workbench 2022, and pop open a raster expression evaluator therein, I can still see all of my expressions. Presets are actually tied to the user, not the version. So as long as you're the same user who configured the preset, you'll be able to see them across FME versions and across your workspaces. All right. And now, of course, it's pretty easy to manage your presets as well. If you need to remove a preset, if you're finding you're just not using a few of them, it's easy enough to delete them. So I'll just go and delete that duplicated NDVI preset. And now the changes reflected immediately in this version. And if I were to go back to FME 2022.2, the changes reflected in there as well. So another option available for managing your raster expressions in FME is to make use of a choice user parameter where the choice options available at runtime have been imported from an external source. So let's say I maintain a CSV file of my most commonly used raster expressions when it comes to Sentinel-2 imagery. This is a fairly simple, easy to manage CSV. All I've done is comma delimited the expression name and then the expression itself formatted the way FME expects to receive an expression. What I can then do is configure a choice user parameter. I've called it band expressions, where the choices have been configured by importing the values and the display names from my CSV file. That's fairly simple to do. You simply select Import from Dataset and follow the wizard prompts. Okay, so now I have all my choices configured as a dropdown. If you have one expression that you find you repeatedly use over and over again, you can set that as your default value. All you need to do to apply that user parameter is simply set the expression value of your raster expression evaluator to the user parameter that you've created, and that's it. Choosing Run on your workspace will prompt you to choose the expression that you'd like to apply. Okay, so that's a user parameter method for managing your raster expressions with the raster expression evaluator. So key takeaways from those two demos. Take advantage of transformer presets to recycle those frequently used expressions with the raster expression evaluator. This is a particularly handy recycling technique for workspace authors, and consider applying a choice publish parameter to offer some runtime control over the actions of the raster expression evaluator. And now I'll pass things over to Dave, who will highlight a nice tip about the change detector.
Thanks, Natalie. The change detector transformer detects changes in the data between two versions of the input feature type. This transformer has two required input ports, one for the feature type from the original version of the data, and the other for the feature type from the revised version of the data. Change detector identifies features that were updated, inserted, deleted, and unchanged between the two versions of the data. I will be demonstrating how to view the modified values from the updated output port from the change detector transformer. The goal here is to track the changes between the original version and the revised version of the data. But how do you know which attributes and values were modified for the updated features? The key is to configure the changed output section in the change detector transformer's parameters. This results in the modified attributes and values becoming visible in the feature information pane. Here is a workspace for my demonstration. To the left, you can see the reader bookmark that contains the 2016 Vancouver Parks data, which will be used as original version of the data, and the most recently available Vancouver Parks data, which will be used as a revised version of the data. In the middle, we can see the attribute standardization bookmark, where attributes are standardized to increase the accuracy of the change detection. Here, I am using the bulk attribute renamer for the original version of the data to match the cases for the attribute names to the revised version of the data. Underneath, I am using a spatial filter to select the same neighborhood parks from the revised version of the data to match the original version of the data. Then I am using an attribute manager to remove extra attributes so that the revised version of the data has the exact same attributes as the original version of the data. Now let's open the change detector transformer's parameters. Here, for the update detection key attributes, I am using Park ID. Park ID is a unique ID for each of the parks. For this demonstration, I'll be using match selected attributes for the attribute matching strategy and select all the attributes except for Park ID. For the changed output section, I have not configured this. Let's run the workspace and see the updated output port. On the right, in the feature information pane, there's no information regarding what values has been modified. Let's go back to the change detector transformer parameters and configure the changed output by specifying a value for the detailed changed list name. I will specify the value as _changed. I will press OK and run the workspace. Now, when I click the updated output port, I can see the _changed expose attribute. This contains all the information on what values has been modified between the two versions of the data. The feature information pane updates depending on what features you select in the visual preview. Now let's go back to the change detector transformer parameters and select match all except selected attributes for the attribute matching strategy, and just select the park ID this time. Now when we run the workspace, change detector will detect all the changes including unexposed attributes except park ID. Now, there are even more features detected as updated by the change detector. On the right, in the feature information pane, there are even more list of attributes and values that has been modified. The original data was stored as a map info format, whereas the revised data was a GeoJSON format. This difference in the format between the original and the revised causes even more unexposed attributes to be detected as modified. The change detector transformers functionality is not exclusive to two explicit versions of the data. I can connect the parks data from the reader itself and connect it to the original input of the change detector transformer and run the workspace. Now I have 89 features detected as updated. There are more features detected as updated because I have removed attributes in the attribute manager for this demonstration. Knowing which attributes and values were modified is particularly useful to incorporate a sense of quality control and assurance during the authoring stage of the workspace. Key takeaways from my demonstration include attribute standardization and the use of unique IDs for update detection key attribute for accurate change detection, modifying the attribute matching strategies to check beyond the exposed attributes, and the ability to verify the modified attributes and values for quality assurance and quality control. I will now pass it back to Elizabeth to wrap us up and go through the resources.
Awesome. Thanks so much, Dave. That was incredible. Thank you so much, everyone, all our presenters, for sharing those tips and tricks and interesting insights across those different transformers here today. Really appreciate all those insights, and I hope you all did too as our audience here today. So I'm just going to take us through some resources to help wrap us up here and help you get started. I want to note right off the bat that we do have the full gallery of our FME transformers. We have a page dedicated for that where you can filter and view our full transformer gallery. Of course, yeah, we showcased these 6 today, but there are many others that you can leverage in your workflows. So I was taking a look at this page. It's actually quite handy. There's different transformer categories that you can filter through, and also a quick reference PDF guide if you prefer that kind of format to look through these transformers with. In terms of other resources, we are all about free resources here at SAFE. I'd encourage you to check out our FME Academy with instructor-led free training for guided learning at your fingertips, and our webinar program. We have lots of on-demand webinars, as well as a great selection of ones upcoming that I'd encourage you to check out. In terms of next steps here today, we'd encourage you to get in touch with us, info@safe.com. We'd love to help you get started with anything data, so feel free to shoot us an email there. And then we also have our FME Accelerator course. It's just 90 minutes free of charge, and it's a great place to get started with FME. You can claim your community badge if you are a member of our community. The code today, I'll just drop that in the chat here as a thank you for joining us. And then if you are not yet a member of the community, or if you have yet to take a look at that, I'd really encourage you to take a look. It's a great place to network with other users and experts alike. There's a lot of great forum discussion opportunities there.
Awesome. Thank you, Elizabeth. I'll now be taking us through the live Q&A portion of today's webinar. Yeah, if I can just ask our presenters to join me on stage and we can take a look at any of the questions that come in. Awesome. Yeah, it seems that The webinar was super informative and we didn't get too many questions from the audience throughout the session. We did get some from Natalie's section, but it seems that she's answered them. So I'll just pause and see if any additional questions roll in. But in the meantime, if our presenters had anything they wanted to highlight for our attendees today, feel free to jump in.
I just actually want to say that so all the workspaces will be available to download. So I'd recommend anybody who has any interest in any of the transformers mentioned to download some of those workspaces, and you can just kind of work around and play around and see all the different kind of settings you can work with and just get familiar with them.
Awesome. Thank you, Donal. Yeah, they'll definitely be shared after the webinar. And the slides and the recording will also be shared if anyone was curious about that.
Yeah, some of the slides also include links to articles that we worked with, so that could be helpful as well.
For sure. Yeah, if anyone is wanting to get the slides, they'll be shared after the webinar, but they're also under apps and handouts as well, if you wanted to take a look at those.
Yeah, even though there's not many questions, I love all the chat and the creativity at the start too, with all of the transformer names like the dishwasher loader and launcher, the cat whisperer, it's a good one as well. Yeah, so many good ones. So shout out to those as well.
Yeah, thanks so much to everyone for engaging with us. Thank you so much to everyone for joining us today, and thank you to our presenters for being here. So, okay, bye.
Bye.